Good morning. Today we are going to discuss very important topic, polarization from the chapter wave optics. Now, what is polarization? Polarization is nothing but a technique by which we can make an unpolarized light into polarized light. Now, what is unpolarized light? Let me read out what we have written. A light which has the vibrations in all the directions is known as unpolarized light. Now, you can say that if the light has two vibrational direction, then it is unpolarized light. Now basically pictorially we used to define this diagram to define unpolarized light. So one dot and another arrow. Now dot define vibrations perpendicular to the plane of paper and arrow define vibrations in the plane of paper. So you see in the figure you do have two vibrations. It means the light is unpolarized light. Now if you want to make it polarized, what you have to do? You have to filter one vibration. Now let me read out what we have written for polarized light. A light which has the vibrations in a particular direction is known as polarized light. Okay. For example, this one. So you are separating or you are filtering vibrations. So only arrow is there or only dot is there. Then it is your polarized light. Now to make unpolarized light to polarized, you have to use polarizer. Now what is polarizer? Let me read out. A polarizer is a device used to produce plain polarized light from the unpolarized light passing through it. So if you send an unpolarized light through a polarizer, it becomes polarized. Now some polarizer are tourmaline crystal, nickel prism. Now here what we'll do, we'll try to demonstrate an experiment considering tourmaline crystal. Now you see the source is there and source sends unpolarized light. Combining two vibrations. Now we are sending that unpolarized light through a polarizer. Now the polarizer has infinite number of slits are there, but the slits are parallel to a particular vibration. Now the slits as it is parallel to a particular vibration, so that vibration will pass, but a rest vibration gets blocked. So when the light comes out from the polarizer, you will get polarized light. Now you can check whether the light polarized or not if you place the tourmaline crystal again, because tourmaline crystal can be used both as a polarizer as well as an analyzer. So if you keep the tourmaline crystal again parallel to the, considering the slits of the crystal parallel to the slits of the crystal that we consider as a polarizer, or you can say if the slits of both polarizer and analyzer are parallel, then you will get light from the analyzer. So when light passes through the analyzer, you will get light. But if you place the analyzer in such a way such that the slits are perpendicular to the slits of the polarizer, then you will see no light. So it means the vibrations confined in a particular direction. Now there is a law that defines the light that comes out through the analyzer. Now you see here two plane of transmission is specified. One is plane of transmission from the plane of polarizer, another one plane of transmission from the plane of analyzer. Now here we have seen that if the plane of transmission of analyzer is parallel to the plane of transmission of polarizer, then you will get light. But if it is perpendicular, then you will not get light. But if the plane of transmission of polarizer and plane of transmission of analyzer is at an angle other than 90 degrees, so what will happen? Some light will comes out through the analyzer. So that can be defined by law of Melas. So you see the plane of analyzer or plane of transmission of analyzer makes an angle theta with the plane of transmission of the polarizer. So from the polarizer you will get a light with a specific amplitude a, small a, and both plane of polarizer and plane of analyzer makes an angle theta. So amplitude a has a component a cos theta and a sin theta. So if we are interested in defining the intensity of light that comes out through the plane of analyzer, what we have to do? We have to consider the amplitude part of the light, that is your a cos theta, and we know intensity is proportional to the square of the amplitude. So I proportional to a square cos square theta, or I equal to k a square cos square theta. K is your constant, so k a square we are considering I naught, so you will get I equal to I naught cos square theta. This is your law of Melas. Now let me read out what we have written in the statement. When a beam of completely plane polarized light is incident on an analyzer, then the intensity of the resultant transmitted light from the analyzer varies directly as the square of the cosine of the angle between the transmission direction of the polarizer and analyzer. Okay, and we have got this one by considering intensity proportional to the square of the amplitude. As we are interested in defining the intensity of the light that comes out from the plane of analyzer, that's why we have to consider the amplitude of the light that comes out from the analyzer. That is nothing but is your a cos theta. And if we are interested in defining the intensity, then we have to take the square of the amplitude of the light that comes out from the plane of analyzer. So I proportional to a square cos square theta, I equal to k a square cos square theta, and k square is your I naught, so I naught cos square theta. Now there is another law, Bridge-Towards law. Now you see an unpolarized light is there and it strikes at the interface separating to medium 1 and medium 1 and medium 2. So a part of light gets reflected and part of light gets refracted. Now if you want to make a unpolarized into polarized, you have to strike the ray at a specific angle at which the refracted ray and the reflected ray are perpendicular. If this happens, then the reflected light is polarized. Let me repeat once again. If you want to make an unpolarized light to polarized, you have to strike the unpolarized light at any specific angle at the interface with the normal such that the reflected ray and refracted ray are mutually perpendicular. If this happens, then the reflected ray is polarized. So here I equal to R from the law of reflection, and sin I by sin R dash, that is from Snell's law, refractive index of second medium with respect to first medium. So R plus 90 degree plus R dash equal to 180 degree. So R dash equal to 90 minus R. So n to 1, refractive index second medium with respect to first medium. Sin I by, in place of R dash we can write sin of 90 minus R. Sin of 90 minus R is your cos R, and I equal to R, that is your cos I. So sin I by cos I is your tan I. So this is your Bridge-Towards law. It says that tangent of the angle of polarization. Here I is nothing but the angle of polarization, because you are striking the ray at the angle I. That's why the light get polarized. So I is nothing but the angle of polarization. So you can say tangent of angle of incidence or tangent of angle of polarization is equal to the refractive index of the medium. This formula is very important because numerical used to ask, so you have to use directly. So this is your Bridge-Towards law, tan I equal to n to 1. So please go through this part and try to find out your doubts and check out. So unpolarized light composed of vibrations more than a particular direction, and polarized light composed of vibrations only in a specific direction. That is the difference between polarized light and unpolarized light. And you can make unpolarized light to polarized light by using a polarizer, and same polarizer you can use as an analyzer. And two laws, law of Melas, and another one is your Bridge-Towards law. So this is all about. Please go through. Thank you.